All right, so here's what a question in the first section of your homework is going to look like. This is Delta Math. Actually, I think I'll go to the next one. We'll do this one first. So it says, let f be the function graphed below. If four subintervals of equal length are used, draw rectangles whose area represents a left Riemann sum approximation of this. Okay, now here's the trick. I haven't really explained what this symbol means yet, and I don't want to go there. But for now, I want you to understand that your job is to find the area under this curve. Okay, so you're trying to find the area under this curve, like this, but bounded by these two axes, but only from x equals 1 to x equals 5. So this blue space right here. Okay, now I know it's from 1 to 5 because that's what these numbers here are telling me. That's telling me where they want us to start and where they want us to stop. Okay, so you're finding the area of this blue space. Okay, now they also explain in the directions that you're going to divide this region, excuse me, into 4 subintervals. And remember, we want them to be equal in size. So you're going to first look at where they want you to start and where they want you to stop. And remember, those are your A and your B values. That's what we call them. So if I want to start at A and I want to end at B, how wide is each rectangle, each subinterval going to have to be to make them equally spaced? Remember, this is a pretty simple computation where you're going to take b minus a divided by the number of subintervals that you want. In this case, it is 5 minus 1 divided by 4 subintervals, which gives us a width of 1 unit for each interval. So that would be the number you put right there. Okay? Now, when you do this in Delta Math, when you type in this number, you're going to hit go, and it's going to draw you rectangles. Okay, so here's the next thing. You're going to have this already drawn for you, but I'm going to draw them to show you how you would do it on your own. Left Riemann sum approximation. So that means I'm going to draw rectangles, and the left corner of the rectangle is going to be on the curve. So if I put a point, I'm going straight up from the beginning number. If I put a point right here, I would want to draw my rectangle so that the left corner is right on the curve. So there's rectangle number 1. Go to the next 1 unit apart, right? That's how wide they have to be. 1 unit apart, draw another rectangle. 1 more unit apart, draw another rectangle. See how the corner of each of these rectangles is right on the curve? Well, not that one because I can't draw a straight line. The corner needs to be right on that curve each time, okay? And you have 4 subintervals, so you have 4 rectangles. All right, now, you don't actually have to compute the area in this question. You just have to answer some questions that show that you understand how the answer would be interpreted. So it says, the shaded area above representing a left Riemann sum. So like when you do this, this will all be shaded like that. They'll draw the rectangles for you. It'll all be shaded like that. Is a, and your options here in a drop-down box are an over or an under approximation. Which one is it? Is your shaded space bigger than the area under the curve, or is it smaller than the area under the curve? Well, this one is bigger because all the rectangles go over top of the line, giving us extra area that we didn't want in our computation. So this one would be an over approximation of the integral. Integral is what this little symbol is, meaning area. Over approximation of the area, because the function is what? Well, what's the function doing? It's going to ask you, it's going to give you the options like constant, increase, or decrease. This function is decreasing. It's decreasing because it's going down. So that would be what you would have to do. So pretty easy, I think. I'm going to show you one more. The wording is a bit different on this question. We haven't seen one like this yet. So start it the same way. Look at how many subintervals they want you to compute. This one is 3. We want 3 subintervals. So we're going to do the b value, remember that's this number here, minus the a value, that's this number here, divided by the number of subintervals, which is 3. So we're getting 1 again. That's just a coincidence, by the way. This could be literally any number. Picture-wise, what's that mean? Well, that means that we are trying to find the area. Let me get a different tool here. We're trying to find the area of all this space under the curve. All this space under the curve, but only from 0 to 3. So I'm going to shade it in and then I'll restrict it down. So only from 0 to 3. So none of this over here. Just that part. Stop at 3. This is the area we want to compute. Okay? Now, like I said, when you do these examples, you're going to type in the subinterval and then hit go, and it's going to draw you the shapes. This time it's asking for a trapezoidal sum. So you would be drawing trapezoids, which is kind of funky, but I would maybe say mark your width. So we said the width is 1 unit, and we're not going beyond 3. And you're going to draw a trapezoid, which is a little different. So to draw a trapezoid, you're going to go to the beginning of your section and the end of your section and put dots on the curve. Let me zoom in a little more. And you're going to draw a straight, oh God. You're going to try to do better than me, a straight line to connect the 2, okay? Ooh, that's a little better. All right, so straight line to connect the 2, and then you're making the lines go down. These are supposed to be straight lines. You get the point. But this is a trapezoid, right? This is a trapezoid because this is not a parallel line to the base this time. Again, one more time. You draw a point on the curve straight up from the beginning and the end of your interval, and you connect them at an angle, and you make it, that's a trapezoid there. And then same thing here, okay? So when you draw these trapezoids, your next question is this less than the area desired or more? See how the trapezoids are all under the curve? That means this is going to be an under approximation. And the reason for that is that the graph itself is going down, so the trapezoid ends up being drawn under the curve. So we would say it's because the function is decreasing. All right, that's section 1 of your homework. Here's the next part. Now you're going to kind of do it on your own, okay? You just don't have a graph drawn. So if you are a visual person, this may be something that you want to draw a graph for. And it's just a real rough sketch, okay? I have points given, right? I have to use these points here. So 3 is an X value. I'll mark this one as 7. Obviously, this is not to scale. 8, and then I'll call this 10. Real rough sketch, okay? And then maybe we'll say this is 11, 12, 14, 16. And I'm going to plot these like as points, okay? So 3, 11 is here. 7 is at 12. 8 is at 14, and then 16. So the curve, you know, kind of goes like that, I guess. Next part, what is the left Riemann sum approximation from 3 to 10? So just this window here, using 3 subintervals as indicated by the table. So they are telling you that they have broken this up into 3 subintervals, okay, like this. Here's interval 1, here's 2, here's 3. So this is not evenly spaced intervals. They're telling you they want you to set it up just like they're giving it in the table. So what you're going to do is you're going to draw a left Riemann sum, which means left-ended rectangles. So that's where you go to the left of an interval, you put a dot, and you go straight over and make a rectangle like that. So there's one rectangle. I'll go to the next interval, which is from 7 to 8. Start on the left side because this is a left Riemann sum. There's the next one. And then the last one, start on the left side, make a rectangle. There we go. Okay, I have 3 rectangles because they wanted 3 subintervals. Okay, your next step is to find the area of each rectangle. It's just base times height, guys. What is the width of this rectangle? It is 4. What's the height of it? The height of it is 11. So this rectangle has an area of 44. 44. The next one has a width of 1 and has a height, I think it was 12. So this area is 12. 1 times 12 is base times height. And then this last rectangle is width of 2, height of, what was it, 14. So 2 times 14 makes this one an area of 28. And to finish the question, you're just going to add those values. So 44 plus 12 plus 28 gives you, what, 40 plus 44, 84. So 84 would be your solution. Okay, let's do one more. This one's trapezoidal. This one's the hardest kind. So same idea. I think it would be smart to draw a little graph like what we just did. I apologize. I wish I could do a better job with these, but I'm doing my best with the tools I'm provided. It's not real easy to do math on a computer. All right, so I'm just marking down here the X values. I probably should have made that one a little closer. Let me do that. Okay, so let's make a little graph. 10 and 11 aren't that far apart, so I'll make them a little closer, and then we're ending at 15. Okay, and then the Y values are, let's see, this one's 11, and then 7's at 10, so it goes down, and then at 10 it goes down to 7, and then down to 4. Okay, this is weird. Then it goes all the way to 15 again. Or no, not 15, 17. Okay, so that one's going to put us way back up here. All right. What is the trapezoidal sum? So that tells you the shape of the figures you have to draw. So we have to draw trapezoids. We have 4 subintervals, which it's pretty much broken up into intervals anyway. So here's the first one. That's the second one, third one, and fourth one. We have to use those intervals that are provided based on the wording. So we're drawing a trapezoid, okay? So a trapezoid, the only difference is my line will not be parallel to the base. The line will connect the 2 dots together, like that. So there's my first trapezoid. There's my second one. Here's my third. And then my fourth one kind of goes at a different angle because the graph goes back up. Okay. Next part, and this is where things are a little different. To find the area of a trapezoid is a little bit more complicated. Okay, this is the formula for area of a trapezoid. And we have to do this 4 times because we have 4 trapezoids. Okay, in this picture, or this, I'm sorry, this formula, I'm gonna draw a little trapezoid here to show you. The height of the trapezoid is actually like the width of a rectangle. It's down here. And then base 1 and base 2 are these two sides that run parallel to one another. Okay, so height is down here. It's the perpendicular side, and then base 1 and base 2 are the parallel sides. So for our picture here, I need to find the area of each trapezoid. You are going to do this very carefully. So here, I'm going to call this trapezoid number 1. Trapezoid number 1. The area of this is 1/2. Base 1 plus base 2 is the height of each of the sides. So this side and this side. This height on the left is at 11, and this height here is 10. So 11 plus 10 are the bases, and then times height, which is like the width, that looks like it's 4. Okay, that's for trapezoid number 1. Trapezoid number 2. Add up the bases, which that's the side measurements. It's kind of where it hits height-wise. So 10 and was this 7? 10 plus 7 times the width of the interval, which is 3. Okay, be super careful about how you do these, all right? I know this is so tedious. I agree. I promise there's a shortcut coming soon, but for now we have to do this the long way to kind of understand the area concept. Okay, so 7 and 4 were my bases. The width or the height for the equation is 1 unit. And then my last one looks like it's going to be 4 for the left side. Or no, wait, what was that one? 17. That was 17. So 4 plus 17. And the width from 11 to 15 is 4 units. Okay? And I don't have a calculator with me, but essentially you are just going to go through very carefully using PEMDAS and add all this up.